So this is my 5th year, I think, of doing the chip estimates. I've actually been with Synopsys for over 20 years. I go to back to a little startup called Logic Automation, which very few people in here probably ever heard of, and we became Logic Modeling, and then Synopsys acquired Logic Modeling, and that was 20 years ago. And I've done a lot of different things over the years, both in engineering, business development, marketing. The curse of having been with a company for a very long time is sometimes you get lots of different assignments. And one of the different assignments I got not too long ago is what I'm going to be talking about today. Now, in the other years when I've come up here, I've talked about, the latest PHY ports and the new controllers, and there was the Virage acquisition. But what I'm going to talk about today is something we announced yesterday, which is not just IP, it's a company initiative that we're calling IP Accelerated. And what this is going to do, it's going to help you get your chips done faster with complicated systems. So, IP's been used in chips for a very long time. But it's been getting harder and harder. You look at the protocols and how they're evolving from PCI Express to now, we're at Gen 4. Ethernet with all the updates, there's audio-video bridging, time synchronization, and things like that. So the IP just keeps getting more and more complex, and so does the software. You've got, multiple drivers, you're supporting different operating systems and things like that. And then to make it even worse, you're putting more IP on the chips. So, one of my roles in Synopsys is, working with customers on SoC design methodologies. And the chips that you guys are doing today, there's some big, scary chips being done with lots of IP. And, when the marketing guy presents, a PHY and controller, it's 2 blocks that hook up together. The reality is much more complicated. You've got to deal with the clocking. You've got to deal with a reset. We've got power management, and with the government dictating lower and lower power in everything, it's very important to get the power management right. And that can be everything from SoC level to IP specific. So big challenges that you're having to deal with. So what we've done with IP Accelerated is we started, with a Synopsys IP portfolio. We are the #1 interface IP provider. We're the #1 provider in most of the titles in our portfolio. With that broad portfolio, we have put together the Designware IP development kits. So you get hardware prototyping, software prototyping, all part of the IP Accelerated initiative. And in some cases, you may need some help doing customized work. Now, this is key, because what you are getting is a working reference design out of the box. And you can come to the Synopsys suites at 3 o'clock today and actually see a real demo where we're going to put this thing together, boot Linux, and run videos through a USB. Whole thing takes about 5 minutes. But it's not just the hardware. We've also included the software. So there's a software development platform that boots Linux. It's all connected through an AXI tunnel. If you need help customizing subsystems, we're bringing protocol experts to help you. We have almost 2,000 engineers working on IP at Synopsys. And when we're the PCI Express team, they know PCI Express. The USB team, they know USB. And we have people that know multiple protocols, so they can help you get your chips done faster. I use this slide every year. It's just kind of an overview of all of the IP. So from the PHYs, the different controllers, the ARC CPU, the AMBA fabrics, data path, floating point, and logic libraries. So this is the portfolio that we used to build the IP Accelerated initiative. And it's targeting both hardware and software engineers. So from the hardware engineer, literally in a matter of minutes, you have a reference design up and running out of the box. You can change that reference design. So we've put what we would consider a typical configuration pre-built onto the FPGA. You might want to change it. One example would be you're exploring your FIFO depth in an Ethernet design. you've got to get the maximum throughput, right? I mean, that's very important, and the FIFO depth is key in Ethernet. But you're not sure. You know, you do the calculation and you say, okay, I think I can get away with a 4K FIFO. And then you're running lots of simulations and all these kind of things, and you're trying to do performance analysis in an RTL environment because you need those real physical things. With this, you can just go in, change the FIFO depth configuration in Core Consultant, it's the RTL generator, regenerate the RTL. Included with the IP prototyping kits is Protocompiler DX, pre-instrumented debugging, so you can synthesize it, re-put it on the FPGA, and run an experiment. How long does it take? Might take an hour to do the synthesis and place and route. Maybe a little longer, depending on the core. So it lets you do performance testing. From a software point of view, you have both hardware and virtual development kits. Same environment, same configurations to start with. So when we bring up the system, the first thing you'll see is it boots Linux. You make a change, maybe it doesn't boot Linux anymore. Is it a software problem? Is it a hardware problem? Protocompiler DX has done the deep trace instrumentation, and you can hook into the common software tools. For ARC, you know, it's the GNU tool chain or the MetaWare debugger. So you can real quickly find out what the problem is. So it's really, really fundamental change in what IP providers are doing. And here it is, pre-verified out of the box. You have the ARC board, you have the HAPS DX board, and you have the PHY board. Complete reference design, reference software, so we're including the software, all of the hardware you need to run it, including the cables, the SD cards, the power cords, everything you need. So you're not going to get the hardware and then have to look around. You know, where's the cable that connects these boards? It's all in the box. It's documented, and anytime you need to make a change, the entire tool chain is there. So Protocompiler, Core Consultant, and we generate the scripts with the constraints as a function of the RTL generation. So what does this mean to you? This is kind of the high-level step of a SoC prototyping. So you've licensed IP, and you want to do prototyping. And the first thing you need to do is, how do I interface to the external world? You know, it's a USB. I need a PHY. Oh, well, is there a PHY that will plug into the prototyping system? Oh, no, I need to design one. Need to design one. So we can eliminate that. We're shipping a PHY with the IP development kit. So once you've got the PHY and you've got your hardware put together, now you've got to create the reference design. You may not be an expert on the protocol. It might take you a while to figure this out. And then you need to validate it. We have already provided the reference design, and it is pre-validated and running out of the box. So you can immediately start exploring different configurations, save all that startup time, and be doing hardware and software performance analysis and simulation in no time at all. So what's the flow look like? So if you wanted to make a change to the RTL, so let's use USB as an example again. We've pre-configured it with USB 3. You may be doing a product that only needs USB 2. You don't need the extra for USB 3. You go into the configuration tool, Core Consultant, change the parameter, you get new RTL generated automatically, right on your desktop, no waiting for it to come back. Make other modifications if you need. Protocompiler for deep debug and synthesis. Get it the new RTL onto the FPGA. The HAPS DX holds up to 4 million ASIC gates on this board, and will plug into the other HAPS boards. So once you've got your reference, you've tweaked the reference design, and you basically, I now have the PCI Express subsystem I want, you can take that card and put it right on a HAPS system. And all the debugging, oops. Okay, all of the debugging is included in what we're providing, and it works with common viewer tools like Verdi. So everything you need out of the box. For software development, booting Linux, hooking for the debuggers, and you've got two approaches: the hardware or the virtual development kits. So they're both available as part of this initiative. So Out of the box, boot Linux, make changes, try different things. You want to do some virtual simulations because maybe you want to test more with the rest of your system. You don't need any hardware. You can run it pure virtual with the virtual development kits. Supports all the common debuggers. Once again, it's got what you need to get your IP up and running quicker. So the virtual development kits, it's running on Linaro Unix. It's using the ARM Cortex A57 models. So we're not processor specific in this. We use the ARC board because it boots Linux, and you need to boot Linux out of the box. And we happen to have some ARC boards that we could use. For the virtual, we're using the ARM. So no difference. And you can also use a PCI Express to plug it into your workstation and do the cross compiles and things like that. It's Eclipse-based, so it works with all the traditional software tools. Lets you bring up and test things immediately. And one of the things we'll be showing in the suite at 3 o'clock, we're actually doing the hardware demo, but we have a quick video of the virtual demo where you can see that virtually you can move files around and see how that's running on your system and debug it. So what did we do? We changed the business model. We're giving you more to help you get your chips done quicker. Common flow, you have a cost of IP, and you had a cost of integrating the IP. Working with customers, listening to our customers, what we've done is we've taken on more of the integration costs to lower your costs so you can get your chips done faster. Pre-verified subsystems out of the box. Saves you time, saves you money. But you might need more help. A lot of what we see are what I would call shades of gray in the protocols. People do something for a very good reason. You have a product where you need certain things, and you're going to use, say, a PCI Express PHY, but not really in a true PCI Express mode. You might be doing something, something unique to make your product special. So we, with our expert engineers, have put together a team where we can do subsystem integration. We can help you take that subsystem, put it on your SoC. We can work on multi-protocol designs. We have experts on all the protocols that we supply, and we can bring those into your team to help you get your chips done faster. SoC integration, the clocks and reset, they're different based on the applications. The clocking and reset for PCI Express is not always the same in one application to another. And sometimes people miss things when they do the chips. And we can also help with the verification. So when we provide IP, traditionally, and I'm sure all IP providers do this, you get a test bench. So when you get our USB, you get a test bench, you do the configuration, and there's a whole bunch of tests that you can run to validate, that you can, help you learn the IP. Because one thing I've learned over the years, people do not read documentation. They use simulators to figure out what's going on. People always ask, can I use these vectors on my SoC? And the answer is maybe. So when we develop tests for like USB, you have the physical side on one, and you have a system interface like maybe AXI or AHP on the other. And we develop a test bench that we provide with the IP that does all these tests. We know what's happening on both sides of it. When you put that USB in your SoC, I know it's on the physical side, but I have no idea what you've hooked it up to. So will those tests work? Maybe. Maybe not. So we can also bring experts to help take the VIP and the IP in the SoC environment and build your verification environment using your methodologies. So bringing our experts to the table. So that's very quickly what IP Accelerated is. Once again, I'd invite you to come to the Synopsys suites at 3 o'clock, and you can see a real live demo. I'm around all week. I'll certainly hang around a little bit if anybody has any questions. And we hope you'll use our DesignWare IP in your next trip. So thank you very much.